So in these next set of lectures, we're going to talk about causality, the movement from association to causation. So up until now, we've discussed the fundamental study designs in epidemiology. We talked about the case control design, for which, as we all know now, is a design which we begin with people with the disease and without the disease, and we look backward for their exposure. And as has been discussed in great detail, with the case control study, we are unable to assess causation, that is, that the risk factor preceded the outcome. We also talked about the prospective study designs, which do enable us to make some conclusions regarding causation, because in these designs, we begin with the exposure and the unexposure, and we follow individuals forward to observe for the outcome. But now it's important to talk about what is causation, and these next few slides just reiterate what we're measuring when we either design and conduct a case control study or a cohort study. So as we know, with a cohort study, we are typically measuring a measure of risk and a relative measure. And in a case control, we're measuring the odds ratio. But what do these measures of association tell us? And again, do they enable us to make conclusions about X causing Y, or exposure or risk factor causing outcome or disease? Sometimes yes, sometimes no, but we're going to talk now about the key considerations for determining that. So what does it mean that there is an association? Well, as we've done up until now, we've collected data or analyzed data and looked at various measures of association. We've looked at the odds ratios, the relative risks, the risk difference, etc. And these merely provide us with a measure of association between exposure and outcome, right? If we get a finding of an increased relative risk or odds ratio, 1 above 1, then we make some assessment or conclusion that there may be an association between risk factor and outcome. We've also talked a little bit here and there about statistical significance for a test and whether or not that is evidence of both an association and a causal link between the exposure and the outcome. And later on in these set of lectures, I'm going to discuss some common pitfalls associated with statistical significance, specifically p-values. So for now, it's okay to just table that. But now we're really going to talk about, is association the same thing as causation? And even more general, we're going to think about, is correlation the same as causation? But first, it's important to define cause itself. So according to Rothman and Greenland, cause of a disease event is an event or a condition or some characteristic that precedes the disease event, and without which the disease event either would not have occurred or would not have occurred until some time later. That seems somewhat obvious, right? But what is cause in itself? So we all hopefully know now that cause is something that occurs before the outcome, so it must precede the effect. That's an absolute. And the cause itself can be as a myriad of things. It can be some sort of environmental exposure. It could be a person-level characteristic, such as a genetic abnormality or a drug or injury, right? But nevertheless, these are the events that precede the outcome. And it's also important as we talk to keep in mind that the cause can be either a positive one, such as a presence of a particular exposure, or it could also be a negative one, so the absence of that exposure. And then according to O.S. Mitian, who's a pretty well-known epidemiologist, he says that cause is a category of a determinant in relation to a particular reference category that's capable of completing a sufficient cause in some instances in which the reference category is incapable of such completion. That's tremendously wordy in my opinion. It doesn't really get at the true definition of cause in a simplistic way. But what he's talking about is what we're going to talk about next, which has to do with the idea of necessary and sufficiency. David Hume, he says, we may define a cause to be an object followed by another, where if the first object had not been, the second would have never existed. Okay? That's similar to what Greenland and Rothman said. And then Hume, as far back as the 1700s, listed out the criteria in order for cause to be causal. I'm not going to read through these. However, as you'll find later when we talk about the Bradford-Hill criteria, many of these criteria that Hume is discussing are essentially the same as what Bradford-Hill later postulated. Now, what is the overall relevance of causation? In epidemiology and science in general, we hear a lot of statements about X causes Y, right? Smoking causes cancer, HPV causes cervical cancer, etc. However, we epidemiologists lack some common shared single concept about causation. For example, we could say smoking causes cancer, but what do we really mean by that? Are we being lax in specificity? It doesn't say that's the duration of the smoking, the severity of the cancer. So this is a general problem when it comes to statements about cause. Now there are multiple factors in causation. We have predisposing factors, which create enhanced susceptibility to the particular exposure. So an example of a predisposing factor would be one's age. As we age, we may be increasing or decreasing our risk or chance of being exposed to a particular exposure, right? A previous illness is another good example. Having had a prior illness may predispose you for future illness or a more severe form of the same illness the next time around. Another type of factor in causation is an enabling factor, and these are factors that essentially favor the development of the disease. For an instance would be poor nutrition. That itself is an enabling factor. If given another predisposing factor or risk factor, one's nutritional status may enhance or increase the overall risk of developing a disease, as well as inadequate access to care, right? So having risk factor for the potential for developing a disease, whether or not we have the access to intervene and treat or minimize the severity of that outcome can vary, right, depending on the level of care that one has access to. Then the third type of factor is the precipitating factor, and this is where we have the actual exposure to the particular agent. That would be the precipitating factor. And then we have reinforcing factors, and this is the idea of some sort of repeated precipitating factor or exposure to other agents or stress. So the classical definition of causation is as follows. It's a constant, unique, and perfectly predictable connection that is postulated between two factors that any change in X alone induces a subsequent change in Y, right? So X causes Y, as X increases, Y increases, etc. But this is a purely deterministic definition, and it is assuming that everything else is fixed in that context where X causes Y, and that it's replicatable and that it's predictable. This classical definition of causation is incredibly unrealistic, if not even impractical or impossible, right? The only place we really see this purely deterministic role is in the laboratory, right? So here's an example of a simple causal relationship in the physical sciences space. So this is where the causal agent itself is sufficient. That is, it alone can cause the outcome. In this particular sense, the time relationship is short, and then it can be replicated under controlled, fixed settings. So here is a classic example of if you have a mass of gas that's fixed at a fixed temperature, if you put pressure on that mass, it'll cause the volume to decrease, right? And this is a very famous physics law.